Hello, I'm Verdi Arbusto, and this is the Schumann Resonance Harmonics channel on YouTube and Facebook. Thank you for being here. Remember to like, share, comment, and subscribe. If you're new, welcome. I appreciate you being here. Please comment. I appreciate the comments. I read all of the comments. I may not respond to them, certainly, but if I put a little heart and a thumbs up or something, then you know I've read the comment. Not everything warrants my feedback. In fact, most things would be better off me not responding to them. All right, so this is the section of this material. The last video that I did, people just complained that it was difficult to hear. I don't know. This is extremely frustrating. It was good on my end. I don't know what to say. I cranked up the volume on this one, so hopefully you could hear it. It's extremely disconcerting and very frustrating, and it's demoralizing to hear that. After I heard it on my end and it was good, you know, whatever. All right, so onward and upward. This is the next section here in this lesson. I've been working on this lesson for the last week, 2 weeks actually, the 9th, and it's almost the 21st. This gets into 2 weeks. So at this point, I'm going to get into the material, and I'm just going to read through it and be done with this. It's fairly quick. All right, so this is the article is Earth's Electricity, a review of mechanisms which can cause telluric currents in the atmosphere, or I'm sorry, lithosphere, by Daniel S. Hellman. This is a great article I got on academia.edu. This one, the first part of it, I have already done the introduction and the abstract. So this is going on with space phenomena. Space phenomena. And what they have here, 2.1, I'm calling part 8 because I've done some introductory videos that explained why this was so difficult. And so I'm actually at part 8 in my series, and not part 8 in the material itself. So this is 2.1. Here we go. Like I said, this is... their designation is different from mine, just for whatever this is worth. Geomagnetically-induced currents, GIC. The ionosphere is composed of charged particles and located 85 to 600 kilometers above the Earth's surface. Electrical phenomena are caused as the solar wind or space weather impact the ionosphere. The solar wind and space weather create ionospheric electromagnetic phenomena in the radio spectrum, and these disrupt communication. Eddies in the ionosphere also occur, and these create electric currents in situ, that means in place, from the motion of ions. This electric current affects the geomagnetic field, and the resulting geomagnetic anomalies induce telluric currents in the ground. This is GIC. Geomagnetically induced currents can cause corrosion in pipes and pipelines and are a problem at high latitudes where the Earth's magnetic flux lines point towards or away from the surface of the Earth, or other rock bodies or human-made structures such as pipes and cables respond to electrical charges in the ionosphere so that a telluric current is induced in the ground. And the research on this is Osella et al. 1998, Everett and Martinek 2003, again 2004, and Polkinen et al. In 2017. Okay, I'm sorry, 2007. And others have studied this phenomena. Cycles are related to space weather and are dominated by the influence of the sun's 11-year sunspot cycle, whose period predicts emissions of gas from the solar surface. Diurnal variations within this larger cycle have been recorded, and the reference is 2001 in Diodata. I butchered that name. All right, so let me, this chart here, okay, this is a wonderful chart here. This is table 1. All right, so you can see space phenomena, GIC. All right, so they're giving you this chart here. I'm just going to kind of show it. I'm not going to go into all of it, but you can see the different types of charges that are within the Earth. I'm not sure how to put it better than that, but these are all different: volcanic, seismic, fractal emissions, defect charging, piezoelectric effects. You know, so there's a lot of different types of charges in the Earth, and it's important because this is the Earth's heartbeat circuit, that I'm talking about. So it's important to see the different types of ways that energy can move across the plate. So this says, Table 1, causes and periods of Earth electricity. GIC are geomagnetically-induced currents. TID are traveling ionospheric disturbances, and EM is an abbreviation for the term electromagnetic. The ongoing diurnal currents are responsible for the corrosion of pipelines and cables in some location, especially at high latitudes, and have been studied extensively in Scandinavia. And they're given the reference 2006 there. GIC typically are on the order of 200 amperes, which is an A, in man-made conductors with durations of approximately 10 seconds, and they're given these references: 1981, 1999, Polkinen in 2008. The oscillating frequency is typically 0.01 to 0.001 hertz, and that's the reference as Price in 2002. Peak current can be on the order of 2000 amp, and these occur at 10 to 100 times in 100 years. Diurnal flux rates at the suboral latitude are on the order of a few millivolts per kilometer, and the reference is 1964. The strongest oscillation frequency of these diurnal signals is 0.4 hertz and is widespread at different latitudes. The reference is 1964, Mather et al. At high latitudes, the motion of charged particles also creates a distinct radio signal termed the polar chorus, with a characteristic frequency of 300 hertz to 2 kilohertz. That's 2000 hertz. And the reference is 2000, Barr et al. 2000. Polar chorus associated with the solar wind and the peak intensity around 50 millivolts per meter to the -1, as recorded from stations on the ground in Antarctica. It typically exhibits a diurnal variation, and the reference is 2000. Telluric currents, and specifically GIC, were first documented in the 1840s with the invention of the telegraph. Buried telegraph lines are electrical conductors and susceptible to electrical induction. Geomagnetically-induced currents caused interference during telegraph transmissions so that the telegraph needles hung frozen by the signals of the GIC. At first, this phenomena was attributed to weather causes, but it was soon realized that the hung needles coincided with the occurrence of aurora borealis and magnetic storms. And the reference is Walker, 1861. 8.2. Cosmic particle flux. Direct bombardment by high-energy charged particles and radiation coming from solar, stellar, and cosmic sources act generally to form GIC. For example, a gamma ray flare from a neutron star 23,000 light-years away was reported in 1999 as causing VLF amplitude changes of more than 20 decibels from interaction with the ionosphere. The Lyraid, Delta, Aquarid, and Perseid meteor showers have caused phase variations in a 16 kilohertz signal due to globally induced current. For planetary bodies with no atmosphere, this flux of cosmic particles creates telluric currents directly. The reference is 2002. Cosmic ray ions have an energy flux of about 6 times 10 to the 9th electron volts per centimeter per second squared for bodies in the solar system. For Mars, protons and neutrons strike the surface with energy fluxes of around 6,000 and 1,400 MeV per centimeter squared to the negative. That's MeV is mega electron volts, respectively. The reference is 2001. This process is not occurring in Earth's surface at present. The atmosphere intervenes. 2.3, planetary magnetic field plasma. If ultraviolet and X-ray emissions from a star encounter a magnetic field, the interactions will create a plasma of energetic electrons. Such a plasma is created in the Earth's magnetosphere from solar radiation and strikes the Moon's surface as it passes through the Earth's magnetotail, as described in Stubbs et al. 2007. The magnitude of the charging can be several thousand volts, and the reference is 2012. A magnetotail is the distal part of an oblong magnetic field caused in this case by solar wind. I'm going to read that again. And a magnetotail is the distal part of an oblong magnetic field caused in this case by solar wind. That is the magnetotail. So that ends the session here. That's the end of the material. The next one up would be atmospheric phenomena, and to tell you the truth, I'm not sure if I'm going to do this or what I'm doing next. It would be a great module. I originally wanted to do all these different parts. They're not that long. They're interesting enough. I just don't really have a lot of energy for doing stuff. All right, so on that note, thank you all for being here. This is the end of the lesson. Carry on. You're free to do what you were doing before. Thank you all for being here. Remember to like, share, comment, and subscribe. At least comment. I want to hear what people have to say about the videos. And thank you for being here. Have a great, wonderful rest of your day. Namaste.